25 minus 10.
Yeah, kind of, but then you would just make that 15, right? Like so.
I thought it was like 25 minus a is equal to 10.
No equal sign.
Oh, man.
So an algebraic expression, how about this?
25 minus a.
That could be one. Like you could do this, 25 minus a, that would be fine. So basically they're saying that would be your base. That could be the base. Right, you could get all kind of craziness, right? It could be like, you could get like this would work. That's an algebraic expression. So anything basically you can think of can be your A. Now you guys have seen this stuff before. You may not have seen it in this form. But now they're saying M and N are to be integers, and that's not completely necessary. But for right now, we'll just play along with them. So then what's going on in that number 1?
They're A and A are getting multiplied, so the integers add.
Okay, so then like for your notes, if you had AM times AN equals A to the M plus N, that's super good. But like, you probably may have seen that before, but then it was like worded, and this is like good notes. Like, so like.
When you multiply real numbers, or when you multiply like. I don't know what I'm trying to say.
When multiplying real numbers with an exponent, you only add the exponents, you don't multiply the actual number.
Okay, so you got to be a little more specific for this to work, because like what you guys just told me, right, would be like, right, you said like, go ahead, what's happening? You're saying that it could be like 2 to the 3rd times 4 to the 7th. Can you do that?
No, yeah.
Well, I mean, what if it? Well, okay. So how about that? Like, would it? Yes, you can do it, but would it fit into this thing here?
No.
Why not?
Because 2 and
Yeah. So the 2 and the 4 aren't the same, right? So you can do it, but not as is. So then, when you're saying this in words, you need to say when you.
I'm multiplying the same number with integers add.
Okay, so take it easy. When you're multiplying like bases, you add the exponents. Add the exponents. Right? That's what it should say. Or that's what it does say. Okay, so when you guys are doing this as notes, and like I'm not going to check these notes tomorrow or nothing, or Monday or nothing, but at the end of this section, which will only take us a couple days, then I want to see that you have this kind of stuff in it. Okay? All right, so then number 2 is saying when you
Divide both bases.
Divide like bases, you subtract the exponents.
subtract the exponents. Right, and this is on page whatever it is, 13.
Yeah.
What about number 3? Some people like start losing it at 3. What happens on number 3?
When
You have a negative exponent.
you move it to the bottom, so
You make the base with the exponent into a fraction.
Okay, so that's pretty close. And they kind of like they don't maybe put enough on there because what if it was or they have n. Well, if it started down there, would you just leave it down there? No, you would not. Where would it go then?
at the top.
It would go to the top. Okay, so then,
All positives to the top.
oops.
So then you have to just flip that.
Okay, so for your notes, what are you going to say about number 3?
Well, you need to understand.
Yeah.
I would say if the base is a negative exponent on it, move the base and the exponent to the fraction.
Are
And
always
move
linked.
all positives to the top.
Ooh, don't get carried away.
Did you say just
Don't get carried away. That's too much.
when working with numbers containing negative exponents, simplify to get a positive exponent?
And then how?
Before solving?
Okay, yeah, but how? Like, what are you doing to make it a positive? What does it do? So I got both statements up here, right? We got this one. So when it's in the numerator,
Divide by negative
No, so this is in the numerator, right? This is like over 1 right now.
I would just say if you have a negative exponent, you just have to make it a positive.
Yeah, but what are you doing to make it? You can't just make it a positive.
You're multiplying.
So, okay, so look, right? Is that okay if I say that part's in a numerator?
Yeah.
And so then that means it's over what right now?
One.
That's over 1 right
So you
now.
multiply by 1.
No, multiply by 1 is just going to be a minus n.
I don't know why
Multiply
this is so hard, because
by-
it makes sense, but to word it doesn't.
Well, that's like, yeah, right. So that, yeah, no, I agree.
But it wouldn't be divide.
So what if I said use the word move? Don't worry about multiplying or nothing. If you got a negative exponent, to make it positive exponent, you move it to,
Denominator.
if you start it in the numerator, but if it's down here, you move it up to the numerator. All right, so then a negative exponent moves that base to the other part of the fraction. Okay? That's what it's doing. If it's in the denominator with a negative exponent, it goes up to the numerator with a positive exponent. And if it's negative in the numerator, move it down to the denominator. There it goes to the other place, okay?
So we have a negative exponent, it moves.
It moves that base to the other part of the fraction. You know, if you want more explanation, you know, write some more. Again, these are your notes. How much do you need?
Is there a way to simplify the third part of number 3, where it says 1 over a in parentheses with the exponent? Couldn't you just put the exponent back in
Yeah, so,
both?
yeah, and so this is, what you're getting at here is a, let's see, how do I say it? Maybe it helps you,
Just, I'm just looking at that, it's not simplified all the way, so.
yeah, you would think this is more simplified, right?
Yeah.
So they're making another statement that they're saying like, because, and this is only true because this is 1, okay? But they're saying maybe it helps you to bring it out here, and you're allowed to do that. This is where that, what I was saying before, where you guys got to get a little creative. That might help you at some point. I would agree that this one is more simplified.
I was about to say, I don't think, yeah.
But maybe moving it out does something for you later on. And so this is something that you've got to keep in the back of your mind. When you're trying to simplify these things and you're stuck, like you got to go through like the Rolodex, like what else am I allowed to do here? Can I play with it out here? Maybe that helps.
Well, yeah, because it makes no sense though, because if you distributed the n, it'd be 1n and a n.
Yeah.
And then you could just cross them out, so then it'd be 1 over n. Makes no sense.
No, it would be, no, because like this would be 1 times 1 times 1 times 1 times 1.
Yeah, so
Okay,
it's
so,
not
yeah,
the same.
okay.
So when you distribute that, just checking, would it be 1 to the power of n over a to the power of n?
Yeah, and then 1 to any power is just 1, right, except for 0, right?
Yeah.
So then, yeah, so that's why
It's not.
it still works. Yeah, so if this was like a 2, this wouldn't be a true statement. Yeah, okay.
Alright, I guess.
And that little move is going to make more sense, well, it'll become useful when we deal with radicals, okay? All right, so then number 4, I kind of made this thing down here on number 4. This is where I'm looking. Like if you're asked to simplify that, you would say it's what?
1.
Because you're dividing the same thing by itself, right?
Yeah.
Now, if you use the step like on the property number 2 there, you would say, well, I can subtract my exponents, yeah? Because we are dividing like bases. So then you have a n minus
And
n.
then those cancel, and there's just a and a.
Well, it'd be a to the 0, right? And so that's why anything to the 0 is actually 1. Because of this over here. Okay, is that okay? So you can totally just remember like anything to the 0 power is 1, but why does it work? That's how it works. You do okay? You alright? Jason? You? Alright, take it easy. Have a good weekend.
That's easy. There is no first power, correct? Like, or is there?
There is, but like you don't.
You don't really use it.
Yeah, because like right, like a power is like how many times you multiply that thing by itself.
Yeah.
It'd just be
So you're just gonna multiply it by itself. once, like it kind of has no meaning in a way, you know what I mean? So yeah, and that's usually why you don't have to write it. All right, so then what's going on number 5 there?
If you multiply something in parentheses, both numerators, or both bases get the exponent.
Yeah, and so as long as they're being multiplied in here, right, this gets distributed to the exponents.
So as long as they're being multiplied?
Yeah, these have to be multiplied. If there's a plus inside, don't be trying any of that.
Alright.
Right, that's where you got to FOIL and stuff. So that's very important. Only in multiplication situations. And then number 6 here, this is like one of your original ones. Right, power to a power. It is important, like Owen was saying, it is important to understand that you can go left and right or right and left on these. If they're telling you that if they're making a statement in math and they put an equal sign in there, that means you can go back and forth. And again, this comes to like simplifying. Maybe it helps you out here, maybe it helps you in here. And this is kind of like, a personal preference type situation. So right, power to a power on number 6, multiply the exponents. When you're dividing and multiplying are the same. So that's kind of the same statement there. And you can't really see that one. Right, and then I think we talked about this maybe yesterday or something. I talked about it to somebody yesterday, I think. That was you guys, I don't know. But like since it's an absolute value being squared, you can take the absolute value first or second. Like it doesn't make any difference. This is kind of a weird one. But it has to do with the property of being,
So if you multiply or divide anything inside the parentheses, both bases get exponents.
That's correct.
5, 6, and 7.
Yeah, basically 5, 6, and 7. Yeah.
We won't write that.
Yeah, number 8, that's a different one. I usually don't see that one as part of your exponent rules. Alright, so what we're going to do is, there's some more notes to take, but I want to spend some time doing some of your homework. Okay, so when you're ready, you can get on page 24. We got more notes we got to do today, so that we can stay with the other class, but I adjusted the original assignment. Okay?
Yeah, I
So,
heard.
what do you mean?
Huh?
What do you mean?
I heard what the original assignment was.
Yeah.
And I heard that you shrunk it down a little bit.
Yeah, well, we got to do what we got to do. You guys got to know this is like must know stuff.
Are we doing 19 and 20?
Right now we're doing 19 to 31. We're going to do, but we're not going to be able to do them all probably. We only got 25 minutes, so I think 10 minutes of this, maybe a little bit more will be fine. But I will do them, or I don't have to do them, or how do you want to, like,
Alright.
how do you guys want to go about this?
Does the A have anything to do with the answers though?
Say it again?
So does the A have anything?
No, that's just like part A and then part B. Yeah.
Oh, I see.
Yeah.
So it's 19 to 31.
Well, the total assignment for tonight is 19 to 43.
I'm gonna try a couple of these ones. So.
Yeah, let's try them like we can, like if you got stuck on one or because order of operations still, that's still important.
Yeah, I'm just skipping 19 for now.
Well, let's do 19.
What would it be?
Let's do 19.
I have to distribute the power of 3 to the 5 and the Z, right?
Right, because that's number, like on those notes, that was number,
So that's 125.
is that number 5?
Yeah.
Yeah, because remember, the inside thing can be a number, it can be a variable, it can be an expression. So yeah, they're both sitting there. It is an A and a B kind of thing.
So it's 125 to Z to the third.
So that's pretty close. negative 125.
Oh, okay.
No, because when you,
No, because it
It's
is.
negatives, not
It's
multiply.
because you're.
No, the negative is on the 5.
You're
yeah,
multiplying 3 times, so 2 times would be a positive, and then you're multiplying.
That's why. So if the negative was outside those parentheses, then yeah, then you would ignore it,
Being
yeah.
multiplied by, or if it's being powered by 2, then it'd be a positive.
Yeah,
Or
but again, it
4.
depends, like what Eli's saying, like, it does matter where this negative is, because if this negative's outside and this was even, the answer would still be negative.
Yeah.
Because then it wouldn't be connected
But
to
if
5.
it's
Okay.
attached to it.
But yeah, since it's inside, then yeah, that makes a difference. Yeah.
you have to, distribute the negative to the z in that case also then?
So, because we're multiplying, no.
I mean.
Like if it was out here.
If the negative was out there?
Since we're multiplying, no. Okay, because that would be a single term. What you're saying is distributing, that's when you're doing something plus something minus something plus, yeah, okay, so then you would have to distribute it.
So for B, it'd be 5x to the 6th.
Yeah, that's what I did.
Oh, that's what I.
Yeah, right, so yeah, so B, part B,
And actually just 20. 20 was pretty easy.
right, that's B, right?
Wait a second.
Would you, okay, so for 21, would you do the exponent first?
Yeah, right,
Yes.
yes, right, it still matters, right? Order of operation always matters.
So it'd be 4y.
Yeah, that's a very important one.
4y to the 6th or 4y to the 8th?
6, you add.
To the 6th. Oh, because it's.
No, I thought it'd be 2 y.
Oh, no, 4 because it's an exponent. And then it's 24y to
Oh, I
8.
thought you were
Ah,
talking
it's just
about,
us.
they took the actual number, I thought you were talking about the base difference. I'm so confused.
24y to the 8th, right? Is that what you got, Eli? Yeah.
Yeah, that's right, yeah. Oh, no, that's not right. That's close, though.
You gotta add.
What did you say it was?
24y to the 8th.
I got 12
That's close.
y. I got
That's
12
close.
y to the 8th.
24 on this one for sure.
It's 24.
And so let me, like, what is an exponent telling you to do again?
Why to the 10th?
Y to the 10th, y to the 10th. So, right, yeah, so this is a way to think about this one. Right? That's what's really going on, right?
Yeah.
Right? Because that's what an exponent says, multiply that thing by itself that many times.
It's 24 now.
Okay? And so then, for me, what I would do is I would say, okay, 6y squared times 4y to the 8th. And then there's where you get your 24. And then you got to add those exponents, and that's why it's a 10th, like you said.
Yeah, I was about to say, because I was just distributing the exponent, I was so confused, I was 4.
They added the exponents.
Yeah, we do when we're multiplying.
You do what you exponent.
So we're doing power to a power here. 2, this is 2 to the first. 1 times 2 is 2 squared. So then we have to multiply these also.
Okay.
Now when we're down here, right now we're multiplying. And so now we're multiplying like bases. So now we're adding the exponents, right?
Got it.
That is.
So you don't have to, you don't have to write out that thing. I just wanted to show you guys I got this up. Let's do a couple more.
So B would be 3x to the 2nd. That's
3x to the second for B, 3x to the second.
For 23 would it be 7x? Like it'd be 1 over
Just say
7x?
27 over.
7 over x. Yep, 7 over x.
Okay.
Oh, there's part B.
Yeah, there's part B also. Yep, don't forget about that.
Let's
Alright, so then for the B of 23, I can factor out in 3, and then have
Yeah, right, yeah.
4. Okay.
Yep.
I was making sure.
So it's 3x squared
4x squared.
But I don't know which one you guys are.
B for 23.
It'd be 4x squared plus 4y squared.
No, you're doing
divided
craziness.
by 3.
You're doing crazy stuff.
Why wouldn't it just be 3? Because you divide them both after you and then you subtract 1x and subtract over 1y.
Yeah.
Yeah, so it's.
All right, so this is a pretty important thing to make sure we all understand. What is your base allowed to be when you're dealing with exponents? Like it was like the first sentence in that green box. Could be all real numbers. What's another option?
Algebraic expression.
It could be variables or key algebraic expressions. Bless you. So this x plus y is an algebraic expression. So do we have like bases anywhere?
Oh,
Yeah.
You can cross them out.
So there's 1 down here, there's 3 up here. So 1 cancels in each of them. Don't be distributing anything because we got that plus sign, right?
Yeah, I just.
Okay.
wanted to say that. So-
Right, so then 12 over 9, right, that does reduce to 4 over 3.
That'd be 64 over 3.
What are you talking about? 64.
What? Oh, never mind. No. I see what you did there.
Because, right, remember, if you wanted, you could go further in this if you wanted, but then you got to FOIL that. That has to be x plus y and x plus y with a FOIL. Because now we got pluses inside, right? So don't get carried away. Only distribute in if it's all multiplying in there. If it's not all multiplying, don't be doing that. That's bad news. A couple more minutes here, so we can talk about the next part.
Just take away all of the
It's all right. If you know it when you were done with it, then it's good. It's worth it.
Technically, A equals 1.
Which one are we looking at?
25.
So it's 1. Yeah. Right, it's 1. Yep.
Oh, negative.
You got a 1?
Which one are you doing right now?
0 exponent? Number 25.
Would you have to put that?
25b, right? Yep, let's look at 25b.
Would you have to put it in a fraction?
So it's a. So here again, we're at a place that you got to make your kind of decision. Because you got options. You could deal with this negative first. I would do it differently if I was just sitting around doing these problems, but for you guys, what I would suggest is that you do one thing at a time. Right, we got things multiplied inside, we got an exponent outside, so we can go put it to both of them, right, multiplying. So then that would become 2 to the negative second, x to the negative fourth.
Okay.
Don't ever leave a negative exponent in there in pre-calc.
Don't leave it in there?
No.
So now put that in a fraction.
So now put that in a fraction,
1
yeah.
over 2. 1 over 2, 2.
1
And
over
then x in the 4th power.
1 over 2 squared x to the 4th.
Alright. Yeah, that's a lot of that shit.
Right? Next year, we don't have to worry as much about negative exponents, but right now, make sure you don't leave anything in there with a negative exponent. So, make sure I remember these times.
47.
47, yeah, so, let's do one more and then we gotta back out.
Yeah, we did 27 before.
I'm thinking.
Which one?
27.
And 2 to the 3rd power and x to the 5th power.
What's that?
So negative,
25a?
negative 2, well, 25.
Anything that's completely raised to the 0 power is gonna become 1. So the answer is just a 1 to that one.
27 would be negative 2
You said 27 over there?
x to the 5th.
Leah.
So it would be
So I'll do 27a and then I gotta stop so we can do the.
negative 8. You have to multiply the parentheses.
Well, you gotta get as simplified as you can. So I don't know, do we? What your order of operations still makes a difference.
Yeah, you put out the exponents first. And then
Did I write that down right? Oh, I
left.
forgot a 3.
You'll
I
have
got 3.
parentheses and then. Yeah.
It's going to be negative 2 to the 3rd, x to the 6th.
X to the 5th.
6. Power to a power is multiply.
Oh, okay.
Right, so this first part, right, I would do it like this, right? This first part is going to be negative 2, I am going to write it like this. X to the 6.
Oh,
Now, this over here, you got a lot of, these are where you got to come up with your options and what makes sense to you. You are more than welcome to say this becomes 4 to the negative first and x to the negative third. But the way I look at this, especially since it's just to the first, is all it's going to do is bounce it down into the denominator.
And make it all negative.
No, it won't, because that's what's making it go down there is that negative exponent.
So it just be on top.
Because that's what the definition of this negative, that's what it's doing. Then if you think about it, if this was 4 to the negative first, then they would have to come down here as a positive first.
oh, you have to move down to negative 2.
This negative and this negative are not related in any way.
No, I'm talking about like just move
Why did you
negative 2
not-
down to the denominator. 'Cause it makes-
Why did you not distribute the power or the number
Because
3
it's still one.
exponent down to that? Like when I did that, I got 8x to the 6th.
So it should be it should be negative. I just haven't done it yet.
Okay,
So yeah, it should be negative 8 though.
yeah.
Okay.
Yeah.
And so then we're not quite done.
So it equals
That'd be
2,
Oh, you
2,
can
x to
divide
the
it,
third. Negative 2. Oh,
Yeah.
Is that all right?
Yeah.
So, yeah, okay.
Is that all right?
Yeah, I was confused in the beginning.
All right, so for some reason they do this. I think we should do this part first. So I'm going to skip the next part of the notes statement here. Do we remember how to read that?
No.
Can I call that the nth root of a? The nth root?
I did an Einstein stuff for you.
Okay, because right, so that would be the what?
Square.
Square root of a. That would be called the cube root of a. Fifth root of a. Is that all right? Huh? What?
I didn't think it was gonna be that simple.
Well, okay, so then here's another statement. These are definitions. This is a definition. And we're back to kind of something Owen had said at the beginning, right? You might be here and need to be here. Or you might be here and need to be here. Why do you need to be in one place or the other? Because it might help you simplify. Okay? So maybe you got to be able to do that. Go back and forth. Maybe it helps, maybe it doesn't.
I remember delineates.
Right? So then here's an expanded form of that. The nth root of a to the mth power is a to the m over n.
Yeah.
Okay? So the beauty of this is that radicals, right? Radicals are just exponents. And so all those rules that we just did, they're all the same. Okay? So I wanted to say that first because that'll help you get some of the work done that we'll get to.
So it'd be like the 9, 43, whatever, that type of thing.
33.
So yeah, so like 33, let's just do 33. I think this is fairly confusing. I think it's a little confusing, the way they write it, so I'm not going to spend.
Like 9.
Here's some other things, okay? I don't know, that's somewhere in there, page whatever. Oh, we got plenty of time. 47? So you're allowed to play around with these. This goes back to like, when do I do it? When you need to. All right? So then, someone like paraphrase what number 1 is doing.
They're just distributing or dividing the n from, going from right to left, they're just distributing the n.
Yeah, right.
It's at 47.
So what yeah, I said 47 is like when we're leaving. Sorry. Yeah, sorry.
What does that say?
So what this is about, this kind of goes back to those properties in a way. This is basically saying that we can do a to the m first and then take the nth root of that, or we can take the nth root of a and then raise it to the nth power. Either order is fine. It's like yeah, correct. That's what I'm saying. Yeah, it is kind of like the commutative property, right? Right, and so then maybe it makes sense to do it here. Like no one wants to take the cube root of 64. Cube root of 8 is nice and simple. Okay? So maybe it helps you, maybe it doesn't, maybe, bounce around with it.
So you can move.
Okay? What's number 2 giving you, allowing you to do?
Put the bases and then together. And
Oh, yeah, if you're going, yeah. If.
they're
Multiply the bases if the root is the exact same.
Yeah, if your root is exactly the same, then you can play around with that. The root has to stay the same, though. That's what it's saying. So again, when does that help? Well, there's going to be problems, but this will help. They'll give you this, but it's easier to do it here.
You can just make it one step instead of multiple different ones.
So like, let me give you let me do the opposite of what they just did on their example. Let's say it's the square root of 9x. Well, that's the same as the square root of 9 times the square root of x. So then you can simplify it down to 3x. Or I'm sorry, 3 square root of x. All right, 2 and 3 are basically the same, right? Give you some properties there. This is a cool one. This one makes sense. Let me show you what's going on with that. So right, they start with this. And so then what you're allowed to do is say, well, like, look, is that okay if I write that like that? Does that make sense? And so then that's also saying, well, then we can write this inside. Now we have a power to a power, so that means multiply. When you're multiplying fractions, you multiply straight across.
So A to HN.
1 over.
N.
Yeah, but 1 over. 1 over.
Okay.
And then that's equal to just,
Then you can move it back to that other form if you want. Okay, and so what they're doing, right, is they're just giving to you as a statement there. Right, they're just saying that's what it is, but that's how it would work. That's how you can manipulate it to get there, okay? And then number 5, right, because, right, this becomes, like we change it to the other form, it'd be a to the n over n. Anything over itself is 1, they cancel, right, a to the first. Okay, and that's how that one works.
you wouldn't have to distribute, or to do that, you have to distribute the n and then transfer it over, right?
So yeah, I mean, I guess like really you would kind of apply this.
Yeah.
Right, you'd say, okay, that n would come on the inside, and now I can change it to that other format I showed, yeah. And number 6, basically number 6 is saying more or less that you can't take the even root of a negative number. That's more or less what it's saying with that absolute value. All right, so then that takes care, so like if you flip back to page 24, 33 to 43 odd, you're just bouncing in between the forms of, right? You're bouncing in between. Yeah, right. Yeah, that's what they're asking you to do.
Yeah.
So they're saying radical form on 33 is square root of 9 equals 3. And so then the column is rational exponent form. So what they're saying is 9 to the 1/2 is 3. That's what they're asking you to do. Go back and forth between those two forms.
Yeah,
Okay?
Wait, what?
Well, they're giving you two columns, right? Radical form and rational exponent form.
Why would it be 1/2?
It's 9 is to the power of
Square
1.
root and then 1/2.
Is that okay?
So you're doing,
oh my god.
flip the opposite of square root to get you to the power of 9, right? And it's already got the 1 there.
So what you need to understand about this is that this and this are the same. Like the 3 is just like, say they both equal 3. So what they're saying is if you see something to the 1/2, understand that that's the square root of that something. Okay? And so you got to go back and forth in between those two forms.
So like 35 would it be